When we think about functions in a programming language, you might have heard of the black box IPO model, so input, processing, and output, where if you know the input to something and your desired output, the processing can be abstracted away. This is true for programs in their entirety, but also at the function level. So a function can be defined with required inputs or optional inputs, and it will produce some known output based on those inputs. And we don't necessarily need to know how the function performs that processing. A quote from Gemini on Python functions. Functions in Python are reusable blocks of code that perform specific tasks. They enhance code organization, modularity, and readability. By defining functions, you can avoid code duplication, improve maintainability, and promote code reusability. Python comes with a number of built-in functions. A few examples here are print, which prints values to the console. For example, the classic hello world in Python syntax using a Python print function. Length is another built-in function that returns the length of a sequence, and a sequence in Python can be a string, a list, or a tuple. And here's some example syntax for using the length function. If we have a list, 1, 2, 3, and we print the length of the list, it should output 3 because there's 3 elements in the list. Sorted is another built-in function in Python. This sorts a sequence in ascending order. So if our list were 3, 1, 2, we can call the sorted function with our list as an argument. And when we print the sorted list, it's going to output 1, 2, 3. Max returns the largest item in a sequence. Min returns the smallest item in a sequence. So for our list of 3, 1, 2, calling the max function with our list as the argument outputs 3, and calling the min function with our list as an argument outputs 1. This is just a few examples of built-in functions in Python. If you go to the Python docs, you can see a list of all of the built-in functions that are available in Python. And this is an alphabetical list of functions that you can explore and use. But then you might want to create your own functions. Typically, if you find yourself copying and pasting code, that's a good indication that you need to create a function. You should never have code duplicated within your program, and anytime you need to perform the same task or sequence of tasks more than once, then you certainly want to create a function for that. So to create your own custom functions in Python, we'll look at some of the terminology. The signature of the function defines the function's name and parameters. When we talk about parameters, they are placeholders for values that a function expects to receive. Then when we call the function, the arguments are the actual values we pass to the function. So in this image, you see a function using the def keyword, which is how we define a function in Python. That's Python syntax. Predict price, that is our function name. So just like a variable name, there's some rules around what you can use for names, and then there's some conventions as well. Certainly you cannot have a space in a function, so we use the underscore. But you may also see title case or camel case. I personally prefer keeping everything lowercase with underscores. I think it looks a lot cleaner that way. So predict price is the function name, and then the function here has 3 parameters: symbol, days, and use sentiment. And a couple of those parameters have default values, and we'll talk about that in a minute. When you make a call to the function, you actually provide the values that get assigned to those parameter placeholders. And those values are called arguments. So when we call the predict function, we're sending it 3 arguments. The first argument is a string, and it will be made available within the function using the symbol parameter. Second argument 7 will be available as days, and the last argument true will be available as use sentiment. In Python, we have keyword arguments, positional arguments, and default values. Keyword arguments are passed using the keyword name, while positional arguments are passed based on their position in the function call. Default values can be assigned to parameters, providing more flexibility in function calls. In this example, we have a function defined with the name greet, and it has 2 parameters, name and greeting. Greeting is given a default value of hello, and the function simply returns a string that says greeting, comma, name, exclamation mark. Using positional arguments, we can call this function by simply placing the positional arguments in the correct order and using the correct number of positional arguments. So Alice will become name, hey will become greeting. So here we're overwriting that default value of hello by providing an argument for that parameter. So when we print this, we expect to see hey Alice. Using keyword arguments, we can call greet and actually specify which parameter we want to use, and this allows us to skip arguments with default values, allows us to do things in different orders, it allows us to use dictionaries as arguments, and so on. But using keyword arguments, we could explicitly say that name should be set equal to the value of Bob, and greeting should be set equal to the value of hi. So that's just an explicit way to specify the arguments for those parameters. And then we expect this to print hi Bob when we print the result of the returned string. And we can also use the default value. So since greeting has a default value, it becomes an optional parameter. We do not have to specify an argument for greeting. That is optional. And if we do not specify an argument for greeting, then the default value hello is used. So in this third example, we're calling the greet function with a single argument, and the argument will get stored in name, and the greeting will use the default values, so we expect that to print hello Charlie, and you can see the output in this image, hey Alice, hi Bob, hello Charlie, as expected. A couple other things to talk about with functions in Python. The scope of a variable. The scope of a variable determines where it can be accessed within a program. When we are inside of a function, those function parameters can only be accessed within the function. So this name parameter and greeting parameter are only accessible while we are in the greet function. When we leave the greet function, those variables are no longer accessible. And in the same way, we can have variables outside of the greet function that are not accessible within the greet function if they are global variables and we have not specified that we want to use those within the function. So the scope of the variable is what we talk about when we say where the variable can be used, where it can be accessed, where it is visible, where it can be modified, and so on, is the variable's scope. Parameter passing is another concept with functions, and different programming languages have different rules for passing parameters to functions. Python uses what we call pass by reference for mutable objects, meaning objects that can be mutated or changed get passed by reference. And so that means that when the object is passed into the function, if you mutate it within the function, then the object is also mutated outside of the function because it is passed into the function by reference. So it's not passed, the value of the object is not passed to the function, but an actual pointer to it. And where it is stored in memory gets passed to the function so that you can mutate it within the function. For immutable objects, Python passes those by value. So instead of passing an object or a variable into the function, it's simply passing the value of that object, and then you can use the value within the function, but it's immutable. You cannot change the value of that object outside the function. Python also allows anonymous functions. These are lambda expressions. So these are small unnamed functions that we can define using the lambda keyword. So instead of defining a function here, we have a lambda function, lambda x, and this function multiplies a value by itself. And we're storing this lambda function in a variable called square, and then we can simply call square as if it were a function because square holds the value of this lambda function, and print the result of that, and we've squared a number. So calling this function with the argument 5 is going to output 25. We're going to see lambda functions used frequently in pandas when we are performing column-wise operations that we want to specify, and we'll look at that in another lecture series. Functions also have a concept of arguments and keyword arguments. In Python, there's two special symbols, asterisks and double asterisks, that have specific meanings when used in function parameters. An asterisk, followed by args, is used to collect multiple positional arguments into a single tuple and allows functions to accept a variable number of arguments. So you do not need to fix the number of arguments that the function accepts, because you can take all of the positional arguments and store them in a tuple using this syntax. And we'll look at an example of this in a minute. Now, double asterisks, or keyword arguments, collects the keyword arguments into a dictionary. So remember that keyword arguments had explicitly setting the keyword name equal to a value, and we can store those key value pairs in a dictionary using this double asterisk syntax in a function heading. So this allows functions to accept a variable number of keyword arguments. So the different types of arguments that a function accepts that we looked at up here include positional, meaning that the arguments are simply in order, and keyword arguments, where we explicitly set keys and equal to values. So with the star, we can have any number of positional arguments, and those will get stored in a tuple. And with the double star, double asterisks, we can have any number of keyword arguments, and those will get stored as a dictionary. Another thing we can do when we're defining a Python function, and this is optional, we can provide type hints. Python is a dynamically typed language, so you do not need to specify what the type of variables are. But if you want to provide type hints in your function signature to allow other developers, or even yourself when you go back and look at the function, to know what types are expected there and what types the function is expected to return, just to do some expectation setting around that. And it also helps for generating documentation for your function. So here's an example of that same greet function. And here we have included type hints specifying that name should be a string and that the function is going to return a string. Now, this does not change the function in any way. These type hints are simply looked at as documentation. In addition to that, you can specify some actual documentation for your functions to help when you're generating automated documentation for your code. And you can include things like a description of the function, what its arguments are, the types that are expected, and what the function returns. All of the examples that we looked at above are in this code here on this first tab that you can copy and paste to run. So let's give that a shot now. I've copied that code. I'm going to go paste it in my text editor here. Save that, and then I'm going to open a command prompt and run that code. And we can see that it's outputting, hey Alice, hi Bob, hello Charlie, and then 25 for our lambda function. And then this shows the greet function, how it looks with code highlighting in my text editor, with the type hints and the documentation. Of course, we haven't called this function or done anything with it, so there's no output there. I have also included some additional examples on this page. And you can, again, copy this and run them all, but let's go through these examples one by one and discuss them. So the first example is for describing data. So here we've defined a function called getInfo. So I'm just going to copy and paste that function into my text editor I've pulled in here. So the getInfo function takes a list of values and returns a dictionary that gives you a count of the number of values in the list, the average value in the list, the max, and the min. So using Python's built-in functions, length, and then sum, another built-in function divided by length, and max and min, which we looked at. And then here I have some example code. We'll just go paste this in here as well. So here's my data, which is a list of numbers. I call my getInfo function with my data as an argument to the function, and then I can print the information. So if I save this and run it, get my command prompt back out here, execute the code, you see it returns a count of 5. There are 5 elements in data, and average, max, and min values. Now this is printing a dictionary, which the function getInfo returns. If we want to print this a little nicer, if you import the JSON library, which is a useful library for dealing with JSON-like objects, which are dictionaries. Dictionaries are JSON-like objects, and you want to read those or write those, you can use this JSON library to do so. So I'm going to use the JSON library and a function called dumpS. So dumpS means dump string. So this is saying to dump the result info, which is a dictionary, to a string and give it an indentation of 4 spaces. When I do this, I'll run the code again. You can see that the JSON library with the indentation is printing this dictionary in a way that's a little cleaner and easier to read, so more human readable. Let's look at another function, reversing a string. I've seen this function come up a lot in interviews. And of course, there are built-in ways that one might go about doing this, but to just show an example of creating a function that does this. So I define a function called reverse word. It has a single parameter word, and when I call that function, I'm going to send it an argument of the word that I want reversed. And what this function does is it sets the last index. Remember that a string in Python is a sequence of characters. So we're setting the last index in the sequence to the last character in the word. So that's the length of the word minus 1, remembering that sequences are 0 indexed, always starting with 0. Set up a variable to store my result in. And I'm going to use a for loop to iterate the characters in this word. So for I in range length word, and so range being a built-in function in Python, and length word being the length of the input word, this is going to give me a range of 0 to length word minus 1. And as I iterate through this for loop, at every execution of the loop, I is going to store that next number in the range. So I can take my result and I use the plus equals command, which is a command in Python that says to add the new character to the result and store the result back in result. And from my word, which is a sequence of characters, every time this executes, I want to get the last index minus I. So if you think about this, I starts at 0. So the first time this for loop executes, I equals 0. And the word at the last index, which I've set here, minus 0, is going to be the last character in the word. The for loop goes again, I get set equal to 1, and I'm looking for the character that is one character before the last index, so last index minus 1 will give me that character in the word the second time it executes, and so on until I have gone through each character in the word in reverse order and stored them into my new result string. And as an example, I'm just going to print the output that is returned from calling the reversed word function on the word stressed. Get back to my command prompt, run that. And we can see that stressed backwards is desserts. This next example counts the characters in a string. So I'm going to start by taking the definition of the function, and we'll talk about different ways that we can count the characters in the string and different ways that we can call this function. So this function has 2 parameters, the input string and then a Boolean parameter called stripped with a default value of false. So this count chars function, if stripped is true, and of course it's defaulting to false, then the count equals the length of the input string after the strip function is called on it. So a built-in function for strings in Python is strip, and strip will remove all non-printable characters from the beginning and the end of a string. If stripped is false, which is the default, this else clause will execute, and count will be equal to the length of the input string, and this will include any non-printable characters on either side of the string, and then it returns the count. So let's look at some different ways to call this and see what the result looks like. So first of all, if I want to call this function on a, I've lost my screen there. If I want to call it on an empty string, I should expect it to print 0. So I can save that. We'll go ahead and clear this so we can watch it execute. And we can see we execute this and it prints 0. Next, I want to count a sequence of characters. So I'm going to call the function this way. Save that and execute it. And that sequence of characters was 10 characters long. Now I want to look at 3 different ways that I can call this function next and look at how the function behaves if I'm using stripped versus not stripped, and if there are non-printable characters. So a non-printable character is any character that exists in the file but is not visible on the screen. Now, if you're using a text editor or an IDE to execute your code, hopefully it is already showing you the non-printable characters, where typically these will be hidden. For example, in your Word documents or in most plain text editors, these non-printable characters will be hidden. So a non-printable character that I've used here is a space. And of course, in my text editor that does code highlighting, I have set this to show me the printable characters because printable characters have meaning. They do exist in the world of programming, even though we can't see them. The code that is being executed still is aware of them. So when I call count chars, my function, with the input string hi_u, and leave the default stripped equals false, I'm going to get a count of those characters. If there were non-printable characters before and after the string, in this case spaces, this will add 4 more characters to that count when stripped equals false. However, if I want to strip the non-printable characters, and I really only want to count the printable characters in the string, I can override that default by sending true as an argument and setting stripped equal to true, so the first if statement executes and I can count just the characters with just the printable characters. So let's save that code and execute it, see how it runs. And we got 0 and 10 from before, but then the hi_u output 6 followed by 10 followed by 6, which is what we expected. I'll slide this over here. And we can see that there are 6 characters, 1, 2, 3, 4, 5, 6. So this is counting the space in the middle. It is counting that as a character. It's a space character. But in the second case, I'm also counting the characters at the beginning and the end of the string because I have not stripped those off. And in the last case, I have stripped them off. So even though they exist in the argument, this else clause executed and stripped those characters from the beginning and end of the string. So we got back to 6 characters. So that is the output I expected to see. I have another example here of using named parameters. And here is a function that is defined that is going to compute a grade. I'll get my text editor back out and paste that function. And now I want to look at the different ways I can call this function. I can call it with default values. And this function has 1, 2, 3, 4 parameters, the last 3 having default values set. So when I call the function, I only need to specify an argument for the first parameter because the others are all optional, and if I do not specify them, then a default value will be used. So let's execute this and see what it looks like. What did I miss here? This executed nothing. Oh, I missed scores. I needed to put my list of scores. So this is a list of scores from a fictitious grade book. And my function is going to compute a grade based on the score. And again, using the default values here. I can execute this function. And I see that the score of 0 failed, 100 passed, and all the way down the line, all of these grades passed. So look at the function and you see that in addition to accepting the score, you can specify a total points, which is defaults to 100. You can specify the passing grade value, which defaults to 60. And you can specify whether or not you want your grades to be a pass-fail grade. And this can be defaults to true, but can be set to false. So when it's defaulting to true, this if clause is executing. If pass-fail, so pass-fail defaulted to true. So if score is less than passing, passing defaulted to 60. So if the score is less than 60, the grade equals fail. Otherwise, I had already set the grade to pass up here. So we set the grade equal to pass. Pass-fail is true. If the score is less than passing, we'll change it to fail. And in this case, none of the scores were less than 60. If you look at the list of scores, you can see none are less than 60, except for the first one, which was 0. So 0 failed and the rest of them passed. Now, if I want to change let's say I want to change some, and comment, I'm not going to delete this first one. You have the code available over here to copy and paste. Let's say I want to change all of the default values. I can use positional arguments to do that by providing arguments that are in order. So my score S is sent first. I'm going to change the total from 100 to 110. Change passing from 60 to 70, and change pass-fail from true to false. So in this case, pass-fail is going to be false, so the else is going to execute, and it's going to give me a letter grade instead of pass-fail. If I execute that code, I can see the letter grades D, ABC, DBD, based on the number range that is set up in the function here. If I wanted to use a keyword argument, and not specify every single one of the if I didn't want to specify every single one of the parameters, if I wanted to use some of the defaults, but I did want to specify one or more of the parameters to have specific values, I don't have to set every argument if I use a keyword argument. So by using this keyword argument, I am specifying that I want pass-fail set to false, but I don't have to specify total and passing because I use the keyword argument, where before, with positional arguments, you have to have the arguments in the same number and order as they appear as parameters to the function. So using keyword arguments here is going to allow me to let total and passing remain the defaults, and I only have to specify the keyword argument that I want to change. And again, of course, positionally, I'm going to send it the score, which is non-optional and expected as the first argument. So I can execute that code, and I see that the grades changed slightly because I changed the total value. I used the default because I used the default total value of 100. I wanted to show something simple that uses positional and keyword arguments. So I'll copy and paste that code into my text editor. And here we are going to use the any number of positional arguments and any number of keyword arguments to demonstrate that ability of the asterisks and the double asterisks. So the syntax for using that is given here. And if I execute this, you can see the output. And let's look at this for a minute. So when I called my function, I provided 3 positional arguments, and then I provided 2 keyword arguments. And the positional arguments all were stored in a tuple because of this asterisk character here. And then the keyword arguments were stored in a dictionary because of the double asterisk character here. So because I have set this up this way, I can now use any number of positional or keyword arguments. So I can add to this without changing the function signature. Save that, execute, and you can see that this worked just fine as well. The initial positional arguments were stored in a tuple, and then the keyword arguments were stored in a dictionary, and these print statements printed those out. So that's an example of how we can use the asterisks in Python functions. And as a final example, I asked Claude AI to put together an example that combined a lot of these ideas, and so I provided this here for you as well. So a function called train AI assistant, and this is using type hints as well, and multiple different parameters. And you'll notice the formatting is slightly different because we have so many parameters. It's not all going to fit on a line. And so this is proper syntax to use when you have too many parameters to fit them all on a single line and you want to break them down into multiple lines. So train AI assistant takes 1, 2, 3, 4, 5, 6 parameters, but 2 of those parameters are variable numbers. So we can have a variable number of knowledge domains and a variable number of key value pairs in special abilities. And the type hints provided give us that name is expected to be a string, intelligence level is expected to be an integer, and this is combining type hints with a default value, which is valid in Python. So the type hint is that intelligence level should be an integer and the default value is set to 100. Again, knowledge domains is using the asterisks. So you can have any number of knowledge domains. So this should be a sequence of strings according to the type hint. Personality is a string, has a default value of friendly. Sarcasm level is a float, expected to be a float, and has a default value of 0.0. And then special abilities, which is going to be a variable number of keyword arguments, and they are all expected to be of a Boolean value. And those will get stored in a dict because of the double asterisks. And then this returns a type called AI assistant, which we assume is some function, or I'm sorry, some class, so a fictitious class. And then your function implementation would go here. And here we have just used the special word pass, which in Python means that We know that the function is not currently implemented. We're not ready to implement it yet. We just want the function signature here. So pass is necessary to prevent the compiler from throwing an error telling you that your function is not implemented. So the Claude put a comment here that where the function implementation would go, and then use pass so that this code would compile without error. And then calls the function with values, so arguments, setting the name to Claude, the intelligence level to 150, so Claude is assuming it's more intelligent than average here. Knowledge domains, science, philosophy, and humor. So this list can be as long as we need it to be because we're using that variable length parameter. Personality changed from friendly to witty. Sarcasm level was increased from 0 to 0.3. And special abilities, here we have a variable list of key value pairs. Time travel true, telepathy false. So that's just a fun little example where I asked Claude AI to give me an example of a fictitious function in Python to demonstrate just the different types of parameters and arguments, and just to confirm that this code does compile. I'll go ahead and paste it into my text editor, pull out my terminal, and clear that. And I don't expect it to output anything, and it doesn't, but it does compile. So if I were to, if I did not have pass here, now I have a function signature with no implementation. If I try to execute that, I get an error. So we want to have pass there to tell the compiler that we know this function is not implemented, but we intend to implement it later. So I can run it without error. So this covers a lot of different ways we can declare, define, document, and use functions in Python. Of course, there is always a lot more to learn, so I recommend finding tutorials online, practicing, and W3 schools, which I recommend often, give some nice tutorials on using functions as well.